Hey guys, my video is going to be way too long and maybe even hard to upload all at once, so I decided to split it into two, so we're going to pick up where we left off, which is on question 30. So on question 30, it says that the cosine of an angle, so let's say the angle is x, so we have cosine of x is equal to 1/2 of the sine of the angle, so 1/2 sine x, and they're asking us for the tangent of the angle, and we know that tangent is sine over cosine, so we just need to get there. And how do we get there? Well, first let's multiply both sides of this equation by 2, and then I could do that and write that what I have is 2 cosine x is equal to sine x. And now to get tangent, I need cosine underneath sine, so I'll divide both sides of this equation by cosine x, and when I do, on the right side I get tan x, and then on the left side, so I get tan x on the right side, and then on the left side clearly I get 2, so the correct answer is D. Okay, 31. This graph has 1, 2, 3, 4, 5 zeros showing, and we know that an nth degree polynomial can at most have n zeros and n minus 1 turning points. So 1, 2, 3, 4. So we know that a 5th degree polynomial can at most have 5 zeros. A 7th degree polynomial can at most have 7 zeros, but a 7th degree polynomial can have 5 zeros because 2 of the zeros that are missing could be complex zeros that come in conjugate pairs. And remember, complex zeros come as conjugate pairs. So a 7th degree polynomial either has 7 real zeros, or it has 5 real zeros, or it has 3 real zeros, and yada yada. So, but what this graph cannot be is a cubic. Because we have too many zeros, right? And so it cannot be this, but can be these two guys. So 2 and 3. And 32 is talking about a right circular cylinder, which just means that the cylinder is not leaning. They like to say right circular cylinder when they could just say a cylinder. So just want to make sure that you're not stuck on like right circular. That phrase, it just means that the cylinder is not leaning. It also does not comment on how well your cylinder is drawn, which mine is not like very well drawn, but we'll live. It says it's got a radius of 3 and a height of 3. Yeah, I'm like really bothered by how poorly drawn my cylinder was. I am re-recording this like a 3rd time, and first 2 recordings had much better drawn cylinders, but whatever, we'll live. Okay, so they say that A and B are points on the surface of the cylinder as far apart as possible, so that they're there and there, or they're there and there. And the analysis and the answer is the same, so I'll just have them where I have them right now, which is with A being here and B being there. Now, the length that we need to calculate is this length here, and it's pretty straightforward that as soon as you extend this radius to be a diameter, that 3 turns into a 6 right here. You've got yourself a right triangle by which you can find the length of AB. Let's say the length of AB is x. Then we've got a right triangle where x is the hypotenuse. This one side is 3. This other side is 6, right? And therefore, by the Pythagorean theorem, x squared will have to equal 3 squared plus 6 squared, right? And that's 9 plus 36, which is 45, right? Okay. But then that means that x is equal to root 45, which means that x is equal to root 9 times root 5, because 45 factors is 9 times 5, and this is 3 root 5, yeah? Okay, cool. 3 root 5 is B, and so we can keep it moving. And what is next? This was 32. Next is 33. So 33 is an illustration of how like you should pretty much like every single time use your calculator when you've got an equation to solve, because I'll show you how you can solve this by hand, and then we'll solve it by the calculator and show you that the calculator is much more efficient. So if you wanted to solve this by hand, a lot of you will recognize it as quadratic in form. So you can say that A is like sine theta, and then you could write that you've got 6a squared minus a minus 2 equals 0. Now, there's a method called the AC method that helps you with quadratics where the leading coefficient is different from 1. I've mentioned it at least once before in the first part of this solution video. But anyway, you've got 6 times negative 12 is, 6 times negative 2 is how it would work, and that's negative 12. So 6 times negative 2, which is negative 12. And you take negative 12 and figure out 2 numbers that multiply to negative 12 and add to the middle coefficient, which is negative 1. And those 2 numbers are negative 4 and negative 3. And this is what they help you with. Well, now you could rewrite this equation with the middle term here turned into two terms as negative 4a plus 3a. That's why we cared about the two numbers that multiply to negative 12 and add to negative 1. Negative 4 and negative 3 help us rewrite the middle term, which is negative 1a, as negative 4a plus 3a, or we could write it reverse as 3a minus 4a. It doesn't matter which of the two you write, negative 4a plus 3a or the other way around. But yeah, you've got then minus 2 equals 0. And what we're going to do next is group these two together and group these two together. And in the first group, you can factor out a 2a. And when you do, you'll have left 3a minus 2. And in the second two, all you could factor out is a 1. And then you'll have 3a minus 2 left, right? And then this equals 0. So now 3a minus 2 is common to both this first guy and that second guy that are on either side of the plus sign. So we factor it from both guys, and we can write 3a minus 2 times 2a plus 1 equals 0. And then from here, we see that a has to be 3 halves and a has to be negative a half. But wait, a is sine. So we say sine theta is equal to 3 halves. And then sine theta is equal to negative 1 half. And I know our answer comes from the 3 halves one. And of course, what we're going to do is sine inverse of 3 halves. But what mode are we in? We are in, what are we? Radian mode. So we need to change, no, sorry, home mode. We are in radian. Yeah, we are in radian mode. So we need to change to degree mode. And then let's come home. And now we need to do sine inverse of negative 1 half and sine inverse of, oh, that was off the page. Sine inverse of negative 1 half. And then sine inverse of 3 halves. But as I said, the answer that shows up on the choices is going to come from the 3 halves. So sine, not sine, but sine inverse. So sine inverse of 3 divided by 2 is going to be undefined. Did I mean to write 2/3 here? Yeah, my bad, guys. This needs to be 2/3, right? A is equal to 2/3, so sine inverse of 2/3. Okay, so sine inverse of, I should have known sine inverse of 3 halves is not defined, obviously, because, yeah, right. 2/3. I'm just like thinking ahead to what I want to do and not focused on it. And in any case, like I told you that this is a bad idea. You should just use the calculator to solve it. And I actually proved my point even more, because you could have like written 3 halves instead of 2/3 and been either confused yourself or like, you know, like thought that the answer wasn't there, whatever. Like so to avoid all that problem, what you should do is let the calculator solve it. And how? You go to F2 solve and then type the equation exactly as it appears. So 6 and then parenthesis for the sine squared, and then it's sine x squared and then minus sine x and then minus 2 equals 0, comma x. But you can't hit enter just yet because this is a trig function you're trying to solve. And remember, sine and cosine will equal a number between negative 1 and 1, including negative 1 and 1, and which is why, by the way, 3 halves wouldn't have made sense, right? No angle can have sine equal to sine of that angle equal to more than 1 and less than negative 1, and therefore 3 halves doesn't make sense for that reason. Anyway, if you have sine x equal to a number between negative 1 and 1, there are infinitely many angles for which that's true, because remember, sine and cosine go indefinitely to the left on the x-axis and indefinitely to the right? They repeat themselves a lot, but they're periodic functions, but yeah, like that happens. So you normally have to give restrictions, and here it's you're not provided a restriction. It doesn't say like look between this angle measure and this angle measure, but you look at your answer choices. The smallest of them is 9.6, the biggest of them is 90. So you can give the restriction by first hitting this vertical bar, and I want to be like, I want to say 9 and 91. That covers all of our answer choices. And remember, I've changed my mode to degrees, which is very important for you to do. So 9 is less than, and so what I'm saying is every time you solve a trig equation, you have to put this restriction. Otherwise, the calculator will not know which of the infinitely many answers you want. All right, and then hit enter. And it took a little bit of time, but it solved it, right? And definitely much more efficiently than doing all that algebra and all that good stuff. All right, all right. Now, next is the graph of a hyperbola, and we need to find its center. Remember, a hyperbola, and I have room here, which I won't need for this, so I'll use, yeah, so know that this is for 34. But remember, hyperbola has an equation, standard form is x minus h squared minus y minus k squared over a squared over b squared equals 1. Don't get attached to the a and b, right? Which is that like I could write b squared and a squared there if I want. Just remember them as like the number underneath x and the number underneath y. So basically we need to get this guy to look like that, and then the center will be h comma k. But first we need to get this scrambled equation to look like that. Okay, so how do we do that? Well, let's put the x's adjacent, so x squared minus 2x, and we know we need to add something to this to make it a perfect square of the form x minus h squared, right? So let's leave a blank, say plus blank, and then we'll have minus y squared, right? And then minus 4y, and then plus blank, and let's take this negative 4 right here to the other side of the equal sign, so let's have equal 4. I know I'm crowding my writing, and this was like all from the previous stuff, but you'll live. Okay, right? Okay, so there. And I'll write down here at the bottom. Well, now to the x's, we need to add a 1 to make them to make this a perfect square. So we've got x minus 1 all squared, because I just added a 1 there. But then I have to add that 1 on the other side of the equation, so I have 4 plus 1 now on the other side of the equal sign. But from the y's, because we need that minus sign right here, and we don't want it in front of the y, we want it in front of like the factored version of y, right? Like, so yeah, you get what I'm saying? We want the y inside the parenthesis to be positive. In other words, we want this negative to be outside, and so we create a parenthesis, and so we write y squared. And so then since we have a negative in front of a parenthesis, this turns into plus 4y, and then whatever it is that we have to add to make this a perfect square will go inside the parenthesis, and then now, and that's that spot right there, but we put it inside the parenthesis, and now on the right side we've got a 4 plus 1, right? So 4 plus 1. But wait, what is it that I have to add inside the parenthesis with the y's? It's a 4. That way I've got y plus 2 quantity squared. But wait, I didn't add a 4 because of that minus sign. I technically subtracted a 4, and that's what I need to do on the right side of the equal sign. I subtract a 4. So this 4 here and this 4 there take care of each other. And now I've got x minus 1 squared minus y plus 2 squared is equal to, the 4's are gone, is equal to 1. And I guess I could write over 1, so I have my a squared being 1 and my b squared being 1, but otherwise this is exactly in the form that we're after. And since we said hk is a center, 1 comma negative 2 best be the center, and that's right there. And by the way, look at the answer choices. They're so close to each other. They all involve 1 and 2. And so if you make a careless arithmetic error here, that's where, you know, like, yeah, that's where you lose points. Okay, this next question is pretty straightforward, and here's the situation you're dealt, right? So like we need to figure out what the average of e to the x and e to the negative x will be. Like, now you can use your graph to help you graph e to the x and e to the negative x if you don't know what they look like, but I personally know that e to the x looks like this. And it rises very quickly to the right of the y-axis, but yeah, this point is like 0, 1, right? And then e to the negative x is a mirror image over the x-axis of this red graph, which is e to the x, so this is e to the negative x. Oh no, and it comes back down. Sorry, it comes down much lower towards the x-axis, sorry. In any case, this is e to the negative x, and this is e to the x right here, right? Okay, we know that adding them and dividing by 2 is like averaging them. So it's like taking points and then averaging them. So the average would be right there. And the average right here would be like adding 1 and 1 and dividing it by 2. So that's 2 divided by 2, so it will stay there. But over here, I'll have this point on e to the negative x, and I'll have this point on e to the x. Their average will be like somewhere in between. And so if I do that with every point, look at the average, which ends up like somewhere in between. So like here and here, and somewhere in between, the dots that are somewhere in between are going to have a shape that looks like this, right? Kind of looks like a parabola. right? And it goes through that point. So we have two parabolas, this guy and this guy, but this guy has a 0, 0 as a point, which is not possible, right? Like the average of 1 and 1 from e to the x and e to the negative x is going to be 1. So you need the parabola that has 0, 1 on it, and so that's that. And yeah, this page is like the messiest page, but like, yeah, I hope, yeah, you still learned a lot. Yeah, and let's move forward. So 36 now. 36. So this is a silly question, but a nice trick question. They're like, p over r is an integer. Which of the following is an integer? I don't know. 2 times p over r? Because if p over r is an integer, why wouldn't 2 times an integer be an integer? Therefore, answer choice E. Now, for 37, they're telling you that if you like graphed your function f, it has a property that when x2 is to the right of x1, meaning x2 is greater than x1, the value at x2 is bigger or equal to the value at x1. So like this is possible because the value at x1 is smaller than the value at x2. But had we picked x1 and x2 to be like here, like, sorry, now I won't pick it here, like you'll see why, but like let's pick, I could pick it here, but let me pick it here and here. So suppose x1 and x2 are here instead. x2 is still to the right of x1, so x2 is still bigger. But we're also allowed for the value at x2 to equal the value at x1, so we don't need to have like x2's value always being above x1's value. So what we could have over here is like, I could have here the value of x1 and the value of x2 could be equal to it. So our situation is that we need to have a graph that's either horizontal in some parts and increasing otherwise, or always increasing. So that's called monotonically increasing. When you're either increasing or flat in some places, you're said to be monotonically increasing. So instead of a strictly increasing function that just always increases, right? Okay, anyway, the only graph that makes sense here is C. So yeah, next is 38. 38, you know, is basically a system of equations involving two circles because we need to find their point of intersection. But I do not advise you to solve it like you would normally solve a system, which is by elimination and substitution. Here, the easiest way to deal with this is to graph them. And then you could quickly eliminate a lot of silly answer choices and yeah, go from there. Now the first circle, x squared plus y squared equals 1, is centered at the origin, has a radius of 1. So, right, so that circle looks something like this. And the second circle has a radius of 1 and centered at root 2 comma root 2. And you've heard me say I know the value of root 2 roughly 1.4 comma 1.4. And if I did claim that I've been tutoring this test for a while, you should see why I know the value of root 2. But I'm also saying that you should know it too, because like, what do you have to memorize? Like stupid lyrics? Anyway, so 1.41 would be like here, 1.41 would be like here. And so this would be like the center, and the radius is 1, so like should be the same distance, about like that much. So like that'd be like this much. The only place reasonable for the two circles to meet is like somewhere over here, right? It's somewhere over here. So it could not possibly be on the y-axis, because this point is on the y-axis. This I'm not so sure, maybe. It could not be on the x-axis. This I'm not so sure, maybe. But E, definitely not, because this is 1.41 is like root 2. So this is saying that their meeting place is the center of this other circle. No way. So we only have 2 to check, and one of them is 1/2 comma 1/2, which is easy enough to check that this point is not even on either of the circles, let alone being on both of them, which is what the point of intersection would be like, right? So 1/2, 1/2 is not on either circle. I can show you why it's not on either circle by plugging it into the first circle and seeing that we get 1/2 squared plus 1/2 squared. And remember, numbers between -1 and 1, well, let me be more careful. Numbers between 0 and 1 get smaller when you square them. So 1/2 turns into 1/2 squared turns into a quarter. This other 1/2 squared turns into a quarter also. We have 1/2. We need this to equal 1 if it's going to be on this circle, right? And it's not equal to well, it's not equal to 1, and therefore it's not on this circle, and therefore it cannot be a point of intersection of the two circles, right? Okay, cool. So our answer, D, without even checking much. All right, now 39. We see that if we plug in -2 to the numerator and denominator, we get 0 over 0. So this is about factoring, and I know how to factor x squared minus 4 efficiently, x plus 2 times x minus 2, difference of squares, and we can use the AC method to factor the numerator. We can also use trial, but why do all that when you could just let the calculator do all the work? And that's what I would do, which is I'd go to F3, and I'd find a limit, and then I'd type exactly what I have, 2x squared, 2x squared, and then it's plus 3x minus 2 divided by x squared minus 4, and then that's our function, and then comma x comma -2, close parenthesis, hit enter. So 1.25. Thank you. There it is. And then 40 says a function is even if it's defined this way. You should be familiar with even functions if you're taking a Math 2 test. And even just means symmetric about, it also means symmetric about the y-axis. And so 2 to the x is, the graph of 2 to the x is like the graph of e to the x. Like all exponentials, it looks like this. This is clearly not symmetric about the y-axis, so no. And you can graph it using your calculator if you just don't know off memory like me. And then if you're given a polynomial, all of the exponents on x have to be an even number in order for the function to be even. And this is good because that's 2 and it's even, but this is bad because it's 1 and it's odd. So when you have a mixed bag, it's neither even nor odd, right? So we can check that, and this is clearly x to the first, so it's odd. No. Sine is not symmetric about the y-axis, right? Sine looks like this. Goes on indefinitely to the right and left, but it looks like this, about 0, right? So no, sine is in fact a very typical example of an odd function. Typical example of an odd function. And another typical example of an odd function is f of x equals x cubed. And similarly, a typical example of an even function is cosine x, or f of x equals x squared. And so clearly the correct answer here is E, cosine x. It's even. Graph cosine and see for yourself. It's symmetric about the y. Okay, cool. 41 says two cars start at the same point P. So let's say point P is right here. The two cars start, and then they travel along separate highways. All right, so one of them, let's say, goes this way while the other goes this way. And we're told that there's 80 degrees between them. And then, so we have to be in degree mode in our calculator. And then we're asked to find the distance between them once they've both gone 110. Right? Okay, so this is screaming law of cosines, right? You're given side, angle, side. That's law of cosines. Let this side be x. And then you've got by the law of cosines, which says c squared is equal to a squared plus b squared minus 2ab cosine of c. And yes, you need to remember this for this test. So then you have x squared is equal to 110 squared plus 110 squared minus 2 times 110 times 110 times cosine of 80 degrees. So do this in your calculator, and then don't forget to take the square root, and then you'll get the answer. So let me make sure we're in degree mode. Yes, we are. So otherwise, I do 110 squared plus 110 squared. So I could just do times 2. So 110 squared times 2. So 2 times 110 squared. And then my minus 2 times 110 squared. And then times cosine of 80, right? So cosine of, that's a 5, 80. Okay, so this is that, and then I raise it to the 1/2 power, which is 0.5, and 141.41. That's 141 right there. Yeah? Okay, cool. So what's next? This guy, yeah, okay, it's about lines and shading. Let's get the equation of the two lines. So first, this line, there are 2 points. It goes through the origin and 1, 2. So its slope is up 2 over 1, so that's 2. So we see that its equation is y is equal to 2x. What about this other guy? It goes through -1, 1, and 0, 0. So I know its equation is y equals -x. But we want to shade above this line and above this line, which means that we need to turn these into greater or equal to, and they're not dotted, they're solid, therefore the greater or equal to part instead of strictly greater. Yeah, so we need this to also be that. So we could rewrite this first one to say y minus 2x is greater or equal to 0. Or we can write this other one to say y plus x is greater or equal to 0. Now, this is greater or equal to 0. This is greater or equal to 0. So if we multiply them, then we should get something that's greater or equal to 0. So we get that y plus x times y minus 2x has to be greater or equal to 0. One of the answer choices best say this. So that is answer choice C, right? Y minus 2x times y plus x is greater or equal to 0. All right, got it. And next is 43. And what does 43 say? It says that we're given f of n is equal to 1 over e to the n. Notice that we can say that f of x is equal to 1 over e to the x, so it doesn't matter. And so then we'd be seeking where f of x is less than 0.0001. So this is saying f of x is less than 1 over 1 followed by 1, 2, 3, 4 zeros. 1, 2, 3, 4 zeros. Okay, fine. First, let's figure out where f of x is equal to this, right? By the way, f of x is equal to this guy, right? 1 over e to the x. So let me actually, instead of working with this, work with 1 over e to the x is less than 1 over 1, 2, 3, 4. Now, if you've got two fractions and an inequality, you can flip them both, but you have to change the direction of the inequality. So what I'm saying is we could next write that from this, we could write that we have e to the x is greater than, e to the x is greater than 1, 2, 3, 4. This is what we're trying to solve for. Well, let's figure out where e to the x is equal to this number, and then we could decide when it will be greater. So e to the x, if I bring up my calculator, is down here. So let's figure out using f to solve where e to the x, right? E to the x is equal to 1, 2, 3, 4 zeros, comma x. And such an x will come about when x is 9.21. So when x is greater than 9.21, e to the x will be greater than this, and therefore 1 over e to the x will be less than this. Yeah? Okay, so then we need an x that is bigger than 9, and it's saying the least integer n, or least integer x according to our change of n to x. Well, so the least integer greater than 9.21 is 10. So there it is. Yeah, okay, cool. What's next? Almost at the finish line. All right. So 44 is pretty straightforward. It says, what is sine A plus cosine B divided by cosine B? So sine A is, clearly sine A is equal to A over C, opposite over hypotenuse. And then cosine B is equal to A over C. And I know that because for two acute angles inside a right triangle, the sine of one is the same as the cosine of the other, but you could also check based on how this is labeled. So in sine A plus cosine B, we have A over C plus A over C, and then cosine B is still A over C. So we've got 2 times A over C divided by A over C, and canceling this and this, we get 2. So that's that right there. 45 says, what is the volume in cubic centimeters of a rectangular solid? So let's draw us quickly a rectangular solid. Okay, so let's say this rectangular solid is this. Okay, and now what? It's got 3 faces measuring with areas 2, 4, and 8. Let's say that the front face and the back face, which look the biggest, have area 8. And then the top and bottom have area 4, and the sides have area 2. Well, what would make this work? Let's see. If we put a 4 here, we'd have to put a 2 there. And since that means we have a 4 here, to make an area of 4 right there, we need a 1 right there. And then the 2 on 1. Oh, nice. What do we want? The volume. So that's 4 times 2 times 1, which is 8. Yeah, okay, cool. Now, 46 is an intimidating looking question, but it's actually really, really easy. So it gives you a piecewise function, but the complication is instead of just f of x, it's got f sub t of x. So that t is kind of like what throws you off a little bit, but it's not that confusing. Right here it says if t is greater than 5, so you know that t is more than 5. I was going to say 5 or more, but no, you know t is more than 5. It's asking you for ft of 2. That 2 is an x value. And these things compare t and x, right? So clearly x is not less than 0 because x is 2. And clearly x is not greater than t because t is greater than 5 and x is 2, right? And so it's got to be about the middle piece, in which case 2 would be less than or equal to 5, right? And so then we know that f sub t of 2 will have to involve this middle piece. Specifically, we know that x is 2, so we know that it will have to equal 1 minus 1 over t times 2. But that says 1 minus 2 over t. There's no answer that says that. We get common denominators, rewrite 1 as t over t. And so we have t over t minus 2 over t, which is t minus 2 over t. Therefore, answer choice E. Yeah? Okay, cool. And then we look at this next guy, which is an interesting question, but not a hard question. So what it says is like that if we've got point D here, we need the x coordinate of point D. So like if we project point D onto the x-axis, we're looking for like this coordinate right there. First, we know that all of the sides of the pentagon are 2, and this is 1. So adding 2, we know that E is at 3. So that answer is gone. But then we have to figure out how much this little bit is and add it on to 3. So to do that, let me focus on that part of our world and show you what we have. Now, we know that a regular pentagon, has each angle measuring 108. So this is 108, meaning this angle right here is 72, and that angle right there is this angle here, 72. Got it. And I know that this is 2, and I know because I dropped a perpendicular from point D here that this is a right angle. And so what I need to find is this x here. I think I've got everything I need to write something about sine of 72. So I could write sine of 72 is equal to x over 2, meaning x is equal to 2 times sine of 72. So I can find x this way, and remember x is this little bit, and then I could add it on to 3 and I'm done. So, and what is this? 2 sine 72. Let's make sure we're still in degree mode. You see how paranoid I am? You best be at least as paranoid as I am when you're taking the test about changing to degree and radian mode. Otherwise, you should take it like, it's like a walk in the park. Like every time you get nervous and paranoid, you'll lose. So if there are like some of you who do sports, you know that if you're afraid of the opponent, then you're ready to lose, right? So anyway, yeah. So that's x, and we need to add it on to 3. So 4.90, is that an answer? Yes, it is, right here. Okay. The only thing you should fear is Jesus Christ anyway. So like, anyway. Okay, so here we're given f, and we're asked for f inverse of 0.4. Our f is like so simple that we could like figure it out. It's pretty easy to see that f of x is equal to 1 over 12x. And so then we could write y equals 1 over 12x, swap x and y so that we can find f inverse. If we swap x and y, we get x equals 1 over 12y. And so then we get 12x is equal to y, and this y is f inverse, right? So 12x is equal to f inverse. And so f inverse of 0.4, so f inverse of 0.4 is equal to 12 times 0.4, which is like 4.8, I believe, but let's try 12 times 0.4, 4.8, yep. Okay, so there it is. Now, here, you should just know that the absolute value of a complex number, a plus bi, which is also called its norm, is equal to the square root of a squared plus b squared. So here, this is simply equal to the square root of 3 squared plus 5 squared. So the square root of 9 plus 25, which is like the square root of 34. So very close to 6. The only number very close to 6 is right here. Yeah, okay, cool. And then finally, 50 says a committee of 3 math majors and 4 history majors is to be chosen from 20 math majors and 16 history majors, respectively. How many different committees can be formed? So you've got 20 math majors, of whom you want to choose 3. And then you've got 16 history majors, of whom you want to choose 4. So this is a very straightforward combinations question. And the way you do this is, well, I know the n choose k formula, but I'm going to use my calculator. And you go to another very important space in your calculator is second 5, where there's number, and to the right of number is ABS in case you need to type absolute value of any function. But I'll return and show you the more important thing underneath there, under second 5, which is probability, because when you scroll to the right, you've got factorial, and you've got NPR for permutations, and NCR for combinations, and we need NCR this time. So we do 20 comma 3, that's a syntax, times, we need to go back and pick NCR, so second 5, again, probability to the right, NCR again, and this time after 20 comma 3 we need 16 comma 4, and I already wrote multiply them. So we do that and we get 2.0748 times 10 to the 6th, which means this answer choice D here. Okay, this is it. And yeah, so if you need math SAT tutoring or SAT subject test tutoring or science, or in fact English, any kind of SAT tutoring, we have a lot of tutors at Helm Tutors, so reach out to us, and you'll see at minimum the kind of quality tutoring you saw in this video. Yeah? Okay, cool. All right, take care, and I hope you found this helpful.